All right. The diagram above illustrates three forces T1, T2, and 100 Newton in equilibrium. Determine the magnitude of T1. So these are the three forces T1 suspended at here, sorry, and then T2 suspended at this top hanger here, and then this is a block with weight 100 Newton that is also drawing the system downward. So these are three forces acting at a point and they are in equilibrium. Equilibrium means they are stable, it's not falling or tilting or moving to any side. So in that regard, they say we should determine T1. So we are going to use what we call triangle of forces, the law of triangle of forces, to resolve this one or to find the value of our t's. So the law of triangle of forces states that when three forces act on a body in equilibrium, that the three forces can be represented by the sides of a triangle. So these three forces we are going to represent them with the sides of a triangle. So the first challenge is how to extract these three forces and place them on the right position of their triangle. Now you see this one is acting vertically downward and this one is acting at an angle towards the top, and then this one is horizontally. So now how do we resolve this? You see that this 100 Newton force, that a line has been drawn on top to show a parallel line has been drawn on top to show its continuation and also indicate the angle it makes with T2. So the first force I'm going to draw out is the 100 Newton force, the one that is vertically downward, like this. Sorry, the one that is vertically downward, like this. Ouch. Okay, don't mind my line there. Okay, so this one is the 100 Newton. This is the 100 Newton. Now the next one I'm going to draw is this T2, and you see it makes an angle of 30 degrees to the vertical, that's to this 100 Newton. So this is T2 that I'm drawing now. This is T2. This is T2. So it makes an angle of 30 degrees. Makes an angle of 30 degrees. So now this T1 here, you see it goes on the horizontal. So if you draw a parallel line there to cut it there, you see that this other place T1 can be represented here. So here will be our T1. Arrow that way. T2 arrow this way. So this is our T2 and this is our T1, and this is our 100 Newton, and this is the angle. So we have represented this in its proper perspective, and if you check this parallel line we drew here, you can see that here will be 90 degrees. So we bring it down there, 90 degrees. So what kind of triangle do you have here? You have a right angle triangle. So this is a right angle triangle. So now we are to find T1. We are going to use any of the trig ratios to find T1. Now you see that there are two unknowns here, T1 and T2 are unknown. So you are going to use the trig ratio that will relate T1 and one known side and the angle. These two sides, T1, T2, are unknown. So if you use a trig ratio that will bring both of them in the same expression, you won't find any. So which trig ratio is going to relate 100 Newton, 30, and T1? If you say sine 30 degrees, sine is opposite over hypotenuse. Opposite will be T1 over T2. So we can take both of two unknowns. We use cos. Cos is adjacent over hypotenuse. Adjacent is 100, hypotenuse is 2, T2. So if you use that one, you are going to use it to find T2. But we were told to find T1. So we use tan. So that means tan 30 degrees will be equals to, tan is opposite, opposite over adjacent. So opposite side to this 30 degrees is T1. That will be T1 over adjacent. So adjacent to the angle is 100. So if you make T1 the subject there, T1 will be equals to 100 tan 30. So if you input that in your calculator, you'll be having 57.74, 57.74 Newton. That is what you will be having. However, if you are interested in finding T2, then you are going to use cosine to do that. So cosine, which is cos 30 equals to adjacent over hypotenuse. Your adjacent there is 100. Your hypotenuse there is T2. So you have, if you make T2 the subject of the formula, you have 100 divided by cos 30. So this will be, if you do that, you'll be having 115, that's 115.47 Newton. So the question said find T1. So the answer to T1 is 57.74 Newton. So if you were to still find T2, this is what it would be. So this is how to do equilibrium of forces when it has to do with triangle of forces, or you say when it has to do with three forces acting at a point to keep the system in equilibrium. Another way you can still find this without going through triangle of forces is to use the law of equilibrium that says sum of upward force equals to sum of downward force. That's if the system is in equilibrium, or sum of forces acting in the left equals to sum of forces acting on the right. So but let's just keep things there. So you like, share, subscribe, and then if interested in one-on-one tutorial online, you can join my WhatsApp group that is in the link in the description. Thank you.